Hello and welcome to the third and final video on the Introduction to Just Another Statistical Program, or Jasp. In this final video, we're going to discuss how to run a correlation, create a scatter plot, run a simple ordinary least squares regression or OLS linear regression, run a multiple OLS linear regression, and how to export APA formatted tables and figures into Word or PDF. So I'm going to go ahead and go back to our JASP session. So we have everything we've done so far. And in this set, we're going to be trying to determine the relationship between GDPPC and corruption, leaving both those as continuous, and leaving corruption in its reverse-coded original scale from 0 to 10. The most basic graph for two continuous variables is a scatter plot. The scatter plot will show us that the two variables appear to be related. We will follow this visual inspection up with two tests. First, a correlation to tell us how tight the relationship between the two variables is. The correlation close to 0 indicates that there is no relationship. A correlation close to 1 or -1 indicates a very close relationship to a perfect straight line, so a perfect positive or perfect negative correlation. Then we're going to run a regression that tells us the nature of that line in question. A line is defined by a slope and intercept, so rise over run. And the regression output will tell us if either of those coefficients, the slope or the intercept, is statistically significantly different than a coefficient of 0. So to start, we're going to go ahead and click on regression. From there, under classical, I'm going to click on correlation. I'm going to move our variable of GDPPC and corruption 2 into the variable options. So now we have our corruption and GDPPC correlation table. It's a 2x2 box. What we're also going to do is we're going to leave this as Pearson's R under the sample correlation coefficient. That's for two continuous variables. We're going to go ahead and say flag significant correlations. I want to get the constant interval and the sample size. Now within this, so the correlation coefficient is a measure of association between two variables. The sign indicates an inverse versus direct proportional relationship. So if it's negative, that's a strong negative relationship. If it's closer to -1. If it's a 0.5 or -0.5, that's about a moderate. 0.2 or 3 is like a small relationship there. So with this, we have a 2x2 table. The diagonals is just a variable with itself, so that's why it's dashed out. And this off diagonals, it's going to be the same information, so we only look at this lower bottom part. Our sample size is 151. We have a statistically significant correlation of -0.89, so a strong negative correlation. And those are a 95% constant interval as well. We can do it now for a scatter plot. Is under the same option with correlations, click on scatter plot. We have our regression line there. We have all our different options that are all the different values. So each country, what was their GDPPC on the y-axis, and x-axis is the corruption score. You can also click on densities. That's going to provide you with the distributions of each variable. And if you click on statistic, that's going to go ahead and report your correlation coefficient there as well. Great. So there's some other options here too if you want, but we're not going to be using those. So I'm going to go ahead and close out of that one. So now we're going to run a regression. A regression provides additional information about the relationship between the two variables, specifically allows you to predict one value of the outcome given the information of the other variable. So what we're going to do is we're going to click on regression, click under classical, click on linear regression. We're going to go ahead and find our GDPPC, move that to our dependent variable. Method's going to stay as entry. What we're going to do is we're going to remove our corruption 2 and put that as a covariate. It's going to be synonymous with a predictor variable or an independent variable. So we're regressing GDPPC on corruption 2. What we're going to do now is we're going to expand the statistics option. We're going to click on confidence interval, descriptives, part and partial correlation, which we'll come back to when we do multiple regression. We're also going to go ahead and click on statistics under residuals. And then what we can also do is, if we click on plots, we can also choose some of the different residual plots here too. Okay, so let's see if anything else we want to click on. Nope, that looks good. So the first thing is, do we have anything? So we have our null model, so no predictors in the model. When we have our H1, which is just going to be our model with one predictor, corruption 2, our R is the same thing as our correlation coefficient, just an absolute value. This is only true for one predictor, the one independent variable, and one outcome variable. Our R squared is how much variability can we account for of GDPPC based on corruption 2. We could count for 80% of that variability. The adjusted R squared is really helpful if you have multiple predictors. It removes some of the potential bias by having so many predictors in the model. Our omnibus regression table also is an ANOVA. So t-test, ANOVA, regression, it's all the same thing. It's all part of the general linear model. Based on this, in our sums of squares, and our ratios, our F statistic is 584. In our degrees of freedom, and this is statistically significant. We're able to account for a statistical portion of variability. What's most important is looking at the intercept. So knowing nothing about corruption score, our best guess at a country's GDPPC is about almost 40,000. That is statistically significant. We can't fit a zero between this 95 lower and upper bound. For each unit increase in corruption, so going from a 1 to a 2 to a 3 and so forth, we have a reduction of 4,761. That is also statistically significant. So for each unit increase in corruption 2, there is a reduction of 4,761 points of GDPPC. And we're going to skip all these other things here too. We can see, okay, it's a little bit detrended for the normality. But essentially what we can do is we can write this equation out as GDPPC predicted equals our B0, which is our intercept, plus negative 4,761.49 times the country's corruption 2 score. And that's what we'd be using for our linear regression. If we add another variable, let's say we add literacy to our covariate, now we have a multiple linear regression. So now we can actually see the adjusted R squared. It's changed because now we have an additional predictor. So it's removed that potential bias from including additional predictors. So it's adjusting for that. Our overall omnibus regression is statistically significant. Looking at our intercept, our best guess when we don't know the corruption score, that intercept for that, it's a little bit lower. It's 22, almost 23,000. Now for each unit increase in corruption, there's a reduction of 3,500 for GDPPC points. However, for each unit increase in literacy, that goes up by 95 points. And all these are statistically significant. Here we can also look at, we have our descriptives of all our variables, our part and partial correlation. So if you square the semi-partial correlation, that's essentially a unique variance accounted for. We can also do things like R changed and collinearity diagnostics. Look at what's the relationship of those variables here too. So VIF intolerance, one is the inverse of the other. They're both fairly low. Great. So now what I do is we're going to show how to export the results out of JASP. And it is quite easy. So just go ahead and click on results. So I can click here, and this whole section I can copy, or I can press Control A. Let's see. So under results, you can go each one individually. Like let's say I just want descriptive statistics, I can copy. Let me open up a new Word document. And there's all the information from descriptives. I can go ahead and if I remove that, let's say I wanted everything. I can go to this overarching results tab at the top of all my output. Click on copy. That's going to copy everything in our session. Everything is going to be there. Go back into our Word doc and paste it. And it has all the figures, all the tables, and you can go ahead and you can change the formatting on this. We can also go ahead and put this into landscape to make it a little easier to read. And you can just go ahead and make modifications. You can add notes and so forth. From there, if you want to put it into PDF, you can just go to File, Save As, and then just change it over to a PDF document. So Jasp is a very powerful open source software that's similar to SPSS. It does also have some different options if you're interested in Bayesian. That's not something we're going to be covering in this workshop series. But you can also go ahead and if you click on this plus option here, there's additional things you can download here too. So if you want more visual modeling, advanced summary statistics, if you want psychometrics like internal reliability, if you're working with meta-analysis or machine learning, or if you want to look at structural equationing modeling, these are all different options you can add in. And you can do mediation analysis. There's SEM. So you can go ahead and create. It is going to be using Lavon, which is R code for that. But there's reliability. So classical Cronbach's alpha or KR20, Kudo-Richardson 20 or 21. There's factor analysis, principal components, exploratory and confirmatory. There's machine learning. It is really nice. I hope this series was helpful and have fun coding.